new flavor in your ear. I'm kicking new flavor in your ear. Like a brand new flavor in your ear. Here comes a brand new flavor in your ear.
Yes, it's always time for marketing analytics flavor in your ear. Hey everyone, this is Professor Eric Riney from Webster University coming to you to talk to you a little bit about forecasting with seasonal data. And what is forecasting? Well, it's simply taking data that we already have and using that to anticipate future occurrences. This is important if we want to do things like manage inventory or to think about ordering parts for manufacturing or how much labor we need in terms of producing a particular product. And so it's easy when we have data that seems to be linear in some trend. It's much easier for us to forecast that data. But when you have data that is seasonal or data that seems to have highs and lows, and sometimes this data could be just that, seasonal in terms of the season. So in the summertime, you might see things like ice cream cones or slushies or travel, which increases because of just the season of it. Christmas time, you have something similar. During the flu season, you have medicine and things like that that will increase. And so it becomes much more difficult for us to determine forecasting if we have data that doesn't seem to really give us a straight trend line. So what I have here is some data, and it says here, the following data are sales of the best-selling items at Riney Beach Mart. Please assist the manager in forecasting the next 6 months' worth of sales. Now, typically what we would do in any kind of forecasting is we first want to look at the data and see how it's behaving, and then see if we could, do a checklist of things to see if we can get a good forecast. So I would first take this data and simply do some type of scatter plot just to see how well the data is holding up. So I'm going to do that really quickly. I'm just going to insert here a scatter plot and see what the data looks like. And let's connect these dots, and that'll give us a little bit more information. And you can see here that this data is really all over the place. There really doesn't seem to be anything that, wow, I could use to anticipate what's going to happen next. One of the things I might do is add a trend line, and I know just looking at this data, a linear trend line probably is not going to work very well, but I'm going to add one anyway just to show you how this information looks. And you can see here, based off of this R square, that this trend line does not fit the data very well. In other words, this trend line does not explain the actual occurrences very well. You have some that are extremely high and some that are extremely low. You have a few data points that seem to be right on the line, but not very many. So if we wanted to try to forecast using this trend line, it probably would not give us the best results moving forward. And we probably wouldn't want to use this if we were planning on inventory levels or manufacturing levels, because we would be significantly off throughout many of our occurrences. So one of the other things we might try, instead of a trend, a simple linear trend line, maybe we could try something like a polynomial. So what a polynomial does is it allows for us to add some curvatures, multiple curvatures in our data, and perhaps that would give us some type of better results. So an order of 2 means we're going to curve down and curve up, order of 3, order of 4, and we can see if we increase this that our R squared really is not improving very much, and the best we could do here in terms of this trend line analysis is to go up to 6. And we can see that that only improves our R squared, our explainability of the data, to about 58%. So we're still less than 60% likely to get something that is conducive to us planning very well. All right. We could do exponential. It's kind of similar from the standpoint, except exponential is only going to go one direction, and it's going to continue going up in that direction. Power is the same way. We could also try a moving average. And what a moving average does is it smooths out the data for us. So we could take multiple occurrences and we can average those together, and we could say that, hey, if we see that, and let me go back to the linear line here first of all, but if we have a linear line explaining the data, and we have data that's below and data that's above, well, if we put these two together and average them, it should give us something closer to this line, right? But here you would have to anticipate how many occurrences you want to put in the average in order to get a smooth data point or a smooth estimation. So if we were to include these two, the second and third occurrence, then it probably would give us a good something close to the line. But look at the third and fourth points. Those are both above the line, and so that's going to give us something above. And so is the fifth point, and the sixth point, and the seventh point. Now the seventh and eighth point, if we were to do those together, we probably would get a decent occurrence. But looking at this, if we were to try to use a 2-month moving average, and I'm going back over here to my moving average, and I'm going to do 2 periods, we could see that, well, it is doing a much better job of trying to follow what's going on in the data, and it seems to be doing a decent job. But one of the disadvantages about using the trend line, where you just add a trend line to existing data, is that it won't actually allow you to do a fit of the trend line. Now we can easily do a fit of this trend line and see how well the R squared fits. So what I'm going to do really quickly over here is do moving average, if we could spell that right. And let's wrap that. Okay, so let's do a 2-month moving average first of all, and I'm just going to say equals average, and I'm just going to take these first two, and that gives me the average of these first two. So what I should expect to see in the next occurrence should be something close to this, right? And actually, I'm going to move this down here because I'm using these first two occurrences to give me this next occurrence. So let's delete that and let's do it here. Equals average. And you really could, I could start here. You know what, I will. I'll start here. And we're using it to anticipate what we should have gotten in this second month. We can't do it for this first month because we don't have a second data point to do it with. But since we have 2 data points, I can forecast or anticipate what I should get here. And we can see that it's pretty close. So I'm just going to copy this straight down, do all the data points down to the bottom. And now what I'm going to do is find my error term. And basically my error term is going to be the difference between what actually occurred and what we calculated or forecasted our occurrence to be. So equals what occurred minus, what occurred minus what we calculated would occur. And we could see that we're $91 off, which honestly is not bad in terms of us forecasting, especially if we're talking about $2,500. All right, so I'm just going to copy this down as well. Now, in order for us to get a good sense or a good understanding of how well our error is working, one of the things that we need to do, if you remember anything about data and anything in terms of the normality of data, you know that error tends to cancel each other out. So the best approach to measuring error is to do what we call sum of squared errors. And sum of squared errors eliminates all of the negatives so that they don't cancel out the positives. So I'm just going to call this SSE, sum of squared errors. Well, actually, I'll call this error squared because I'm not going to sum it yet. So we'll just call this error squared. So the first thing I'm going to do is I'm simply going to square each of my error terms and calculate that all the way down. And one of the things that squaring does in terms of your error terms is that it magnifies things that get further away or that are dissimilar from each other. So the more error there is, the higher your error squared is. If this were just a difference of 1, then my squared error would still be 1. If this were 2, then it becomes 4. And you could see how just a small increase becomes a huge increase when we magnify it by squaring it. All right, so now I can have an overall, and I'm just going to put this up here because I'm going to use this in multiple ways. Sum of error squared term is what I'm going to call this. And it's simply going to be the sum of my error calculations. All right. I can also take the data, and let's just put this above here, and we'll call this R squared. I can do an R squared calculation. So equals R squared SQW, and it's asking me, okay, what do you want to compare to see how similar or how well one explains the other, how well they work together? And I want this side and this side. And actually, right now, I'm not going to include this first one since I don't have a first occurrence. I'm going to, I'm sorry. We need just the y's first. So let's do that. Put a comma, and then what our x's, let's put in this side. And hit OK. And we can see that our R squared here is about 69%, almost 69.5%. And that's significantly better than the 50-something we were getting when we were using simply a trend line that was linear in nature. So this does do a better job of explaining the data when we do a moving average, but you could see that it's still not giving us something that we can have a high level of confidence in. And that's what we want. We want, if possible, wow, it would be nice to have this R squared to be around 95% or higher, but at least 90%. You know, we would like to be 90% confident, or have an explanation of 90% if possible. All right, so remember we used a moving average of 2. If I were to change this and do it with 3 instead, so I'm going to delete this one, and I'm going to start here, and I'm going to change this now and add in this. So now I'm using 3 data points to anticipate, and I'm just going to copy this down. And you see here, because we don't have a data point here, I'm just going to delete these 2 for now. And we could see that our R squared did improve to 73%, so it's getting better as we're smoothing out. We could see that the line here for our smoothing is, well, actually, let's take this out because this is not this line. This is actually the line that was added as a trend line. So I'm going to delete this trend line, and I am going to now add in another data point, just a second data point. So I'm going to select data, I'm going to add data, and let's give this data a name, moving average. What are the values? We can start up here and go all the way down and hit OK. And let's see, okay, that didn't work, so let's try this again. Okay, sorry about that. I figured out what was going on, so I had to put in both my X and my Y values, which I've never had to do before, but anyway. So now we have this orange line, which represents, or which is our 3 month moving average, and you could see how it's kind of following along what's going on. You can see that there's a delay in terms of what's happening, and that's because it's a moving average, so it's kind of looking ahead in terms of what's going on. But, you know, it's doing a decent job, and if we look up here at the R squared, it is about 74%. So, you know, let's try this one more time, and instead of doing just a 3-month moving average, let's try a 4-month moving average. So I'm just going to delete this one, and we'll start with the 4th month, since that's the first time we have enough data to actually get a data point. And I'll do that all the way down. And you can see that now as we begin to add more and more months, it's really smoothing this data out because it's using all of these months and creating an average, which is going to give us something in the middle here. And so the more data points you use in your smoothing or your moving average, the smoother this line will become, and the less you have in terms of understanding the seasonality of data. So the benefit, honestly, of using a moving average is when you really want to smooth out data. So if you have great swings, but they tend to swing above and below almost equally to some linear analysis, then using a smoothing average might work out best. But you can see here, as we begin to smooth this out, and you know this because when we try to just use a simple linear, which is the way this is moving as we smooth it out, is to a linear type of regression, we could see that our explanation is getting worse. We're now back down to 56 or 57%. So if we wanted to use a moving average, the best moving average for us to use would be a 4-month moving average. And we could use that one as, you know, a good estimation, but not the best estimation. So the moving average probably does not work best in helping us to forecast this data. This is where a different analytical technique called additive and multiplicative analysis comes into play. And what these do is that they look at the individual data points and they try to figure out, is there some overall trend in the data? In other words, is the data moving in a certain direction? Can we use that overall trend and then use the seasonality of particular data points, because maybe there is something cyclical in those that we could use to help us then by each period determine how much that seasonal or that seasonality would impact the overall trend of the data. All right, so I'm going to delete this moving average right quick, and I'm going to put back in really quickly this linear trend line with my equation, and I'll put the R squared back in there as well. And let's move this over so you can see it better. Let's move it up here. I'll make it a little bit larger and even bold it so you can see it. So one of the things we see here is that our y-intercept gives us an understanding of, okay, here's kind of the starting point for our analysis. So we should start with anticipating around $2,775 per month. But we do know that we have this beta of negative 26.088. So this means as we move further out, we are actually trending down a little bit. So we're going to, as we move further from our starting point, or as we move month to month, we're actually going to be losing $26. So that's not very good for my writing mark, and I need to look at that overall and see if I can turn that trend line up, but that's for a different discussion. But that gives us a kind of a central tendency, we'll say, of the data. But it doesn't give us an accurate kind of forecast of what is happening for each one of these data points. And that's what we want. We want something that's going to give us an accurate estimation for the data points. So if there is some way I could look at each one of these data points and say, okay, how far above or below are these data points, and can I use that as some type of seasonal effect then as I move forward to say, okay, if it is period 1, it should be a little bit below. If it's period 2, it should be a little bit further below. If it's period 3, it should be above. And use that in some way then to anticipate what's going to happen in the data. So even though the data is trending down, we could still also add in this seasonality. And that's what we want to try to do in our approach. So how do we get this analysis or make this analysis occur? Well, what we need are these various data points. We need something that, and I'm just going to add in, I'm just going to insert a couple of columns here to give me some room on this side. So what we want is we want something that is going to be our trend line and something that is going to be, and actually let's move the trend line down here. Trend, I'll just call it trend. and I'll bold that, and we'll call this base. All right, and I'm going to bold these. And anything that I'm going to use in my analysis, I always do as a highlighted yellow, just so I know I need to make sure those are included some type of way. So my baseline is going to be something similar to this 2774. It gives me a base by which the analysis works its way around. The trend is, okay, which direction, if any, is the data trending? And here you can see with just a linear equation, it's negative 26.088. And we need something similar when we're doing an additive or a multiplicative type of analysis. All right, then we need to also figure out, okay, how many data points do we want in our seasonal effect? We could have a seasonal effect where we only use 2 data points. And if we use these 2, then we would say, okay, 1, 2, then we start over, 1, 2, then we start over, 1, 2, then we start over, 1, 2. And that might not necessarily give us, because if this is 1, and then we're saying start over here, and the same effect that you put here, we want here, well, we could see at data point number 1, and here I'm using, I have week here, but let's change this to month, so we're using the same thing, sorry about that. But if we have month 1 here, month 2, month 3, month 4, but in seasonality, in our cycle of seasonality, we say that our cycle starts over every 2 months. Well, in month 3, our cycle really doesn't start over. And here, I mean, sometimes you can eyeball it and you could see like, okay, maybe it starts over here and this would be 1. Well, okay, maybe this is 1 here. So 1, 2, then it jumps up to 3. Oh, but look at this 4 here. I don't know. It's really hard to tell here what's going on in terms of a good cycle. And if you don't have a good cycle, sometimes a good place to start is around 8. Maybe 7, maybe 8, and then reduce it down from there. Something similar to what we did in our moving average, and just see, you know, which one does a better job of fitting the data. So I'm just going to start here and say 1, 2, 3, 4, 5, 6, 7, 8. I'm going to use 8, a cycle of 8. All right, now I'll just call this cycle. All right, and right now we don't have any kind of data points, so we're just gonna start with anything. It doesn't matter what you start with. So I'm just gonna put in 1, 2, negative 2, negative 1. It doesn't matter what you put in. Negative 1, 2, 1, 2. All right. And I am going to take an average here, this average. But we want to average our cycles, our seasonality. We're going to average that down here. So this is our overall average of seasonality equals average of these. All right. I'm going to highlight these because we need to add these to our analysis. I'm going to highlight this because we're going to add this to our analysis. And we're going to also use the sum of squared errors term in our seasonality as well. All right, so the first thing I want to do is, before we go any further, I kind of want to give you guys the equation for each one of the type of analysis. So we have the additive forecast model and the multiplicative forecast model. And you can see both of them are to predict or forecast, in this case sales, but it could be anything. It's a forecasting model. I'm saying sales here, but you know, it could be inventory, it could be manufacturing, whatever. All right, so in the additive model, what we have, and let's reduce this a little bit. So what we have is the forecast amount is predicted by the base, which is similar to our linear analysis, plus, and if you just comparing the additive and the multiplicative, the reason one is additive and one is multiplicative is because of the type of equation we're using. In this one, we're adding. In this one, we're multiplying. So that's why this is multiplicative and why this is an additive. So here we have the base plus the trend. So which way is it going times the period number. So this is similar to our x value. In a linear equation, this is what you would get. But what we're adding to this linear equation is some seasonal index. In other words, for each time frame, there is some impact that particular month has in this overall forecast. It could be higher than this forecast. It could be a little bit lower than this forecast. And what we want here is to anticipate the seasonality. Down here, what we have is something similar, but again, we're multiplying the base times the trend times the seasonal index. So what we need to do is we need to set up a forecast that uses this equation, and that's what we're going to do. All right, so going back over here to my sheet, there's a couple things that I am going to have to do. First of all, I'm going to move this month period, and remember, this is just indicating what month it is, starting from the first month we have collected data, moving forward. And you can see that we have 30 months worth of data collected here. Now I need to add in, I'll call it my cycle. And what this is the seasonal cycle. All right, let's even put seasonal. That way you know exactly what we're talking about here. Seasonal cycle. And we have 1, 2, 3, 4, 5, 6, 7, 8. What we have decided is that our cycle is going to run in 8-month periods. And then it'll start over. So I'll just copy this and do it here. And then we have a second 8-month. And then it'll start over again. So I'm just going to copy this down again. And so it looks like I have all of my 30 periods. And if I wanted to continue going, I could, and I'll just add on, even though we're not going to go that far down, but I'm going to add that further down. All right, 31. We did say we want to anticipate month 30, I think 6 months maybe out, so 31, 32, 33, 34, 35, and 36. So that would be 6 months beyond what we have in terms of data that we want to forecast. Okay, and one quick thought on this. I am using data going all the way back for well over 2 years. And, you know, if you see that data 2 years back is really irrelevant and doesn't really give you any kind of anticipation of what's going to happen in the future, then maybe you don't use data going that far back. It's up to you to make that determination as an analyst, what's appropriate data to use. But hey, we're saying that it's pretty consistent even going back over 2 years, and so we're going to use that amount of data to anticipate what's going to happen in the future. All right, so now that we have all of the things necessary, we can actually calculate, and I'm going to change this now from a moving average to an additive forecast. All right, and what did we say we needed? So if we wanted to anticipate what this first month data should be, we said it's equal, and it's our baseline, which is going to be this right here, right? And this is going to be the same for each one of my forecast data points. So I'm going to use my F4 key so I can lock that in place. And then we said plus the trend, which is this one, and it's going to be the same for each of my forecast data points, so I'm going to lock that in place, times, and we said we're multiplying this times the month. So the further we go out, similar to this linear trend line, then the more impact this trend is going to have. So if we look at this linear trend line in this negative 26, as we go further out, then we see it goes further and further down. In other words, as we go out here to 30, month 30 times this negative 26 has a much bigger impact than negative 26 times 1 up here. All right. So the same thing here, where as we go further and further out, we anticipate that we're seeing a decrease in sales. So it will be times this month. Now, as I move down, I want this to also move down in terms of months. So I am not going to lock this in place. All right. This is, again, very similar to what I would have in just a regular linear regression. But now we have to add in our additive, our seasonality component. Remember, our seasonality is each one of these, and we're saying in 8-month intervals, or 8-month cycles, we're doing this. So month 1 is the same as month 1 here. I'm going to use a lookup function here, VLOOKUP function. So for each one of these, what I want to happen is that if I am in cycle 1 of the season, then, or I'm sorry, season 1 of the cycle, then I want that seasonality to impact this forecast, whatever this is over here. And if it's 2, then I want this one to be picked up. So I'm going to do a VLOOKUP. If you remember, a VLOOKUP asks us, okay, what do you want to look up? What value do you want to look up? I want to look up this value. And as I go down, I want it to pick up each value. So I'm going to hit comma. Okay, what table array do you want me to search for this, and then pull in other information? So this data, or this table over here, comma, and then what do you want me to pull in over here? Well, I want the forecast to pull in the second column, so I'm going to put in 2 here. All right, and I am going to close that off. All right, so you can see now that because we don't have anything in the base or the trend, then this is only picking up a 1. But if I were to put in a base here of 200, we would see it would change to 201. If I were to put in, let's say it was negative 10 here, then you could see that this is changing. So my formula is working correctly. All right. I'm going to copy this down one more place just to see if it's working here, and it is working here. And the way we know this is we're starting with 200. As we move 1 month out, the trend is that for each month, we multiply that times the trend. So 2 times negative 10 would give us negative 20. So 200 minus 20 would give us 80. 180. And then we know the seasonality that we have arbitrarily put here for our seasonal 2 of the cycle is an increase of 2. So that would take us to 182. So this is working correctly. And I'm simply going to copy this all the way down. And what happened here? Let's see what happened here. Okay, so one of the things I forgot to do up here is this table right here is actually shifting, and it shouldn't be. So down here, down here you could see that my table actually shifted down, and it should be up here. So let's go back up here and correct that. So I'm going to lock this table in place because I'm using the same table as I move down. There we go. All righty. So that's looking much better. And we can see that our error squared right now is completely off. And it's completely off because we're using these arbitrary data points that I just stuck in, 200, negative 10, and so forth. All right, I'm going to copy this information up to these points as well. And let's make sure this has been added in here. So we want to make sure all our data points are being covered in all of our analysis and in our squared. Yep. Okay. So now we have all of the necessary elements in order to do our additive forecasting procedure. The only thing left now to do is for us to actually use solver, because there's no way, I mean, we could sit here and fiddle with this and try to figure out what numbers go in here, or we can use a computer and allow it to do it for us. Oh, I'm sorry. One other thing that I want to add in here is that this average, I mentioned this earlier, and I'm coming back to it now. So depending on the type of analytical procedure we're doing, in this time we're doing the additive. What we want to do here is that we want the overall seasonality to not have an impact. All right. So even though each one of these will have an impact, overall, we want this not to have an impact. All right. So if we're doing an additive type, if we were to add in this, the only way that this would not have an impact is if this average were a 0, right? So if we added this into our forecast, it would not have an impact, okay? So we want this overall average to be 0. So we're going to use solver. We're going to go out here to solver. I'm going to go up here to data, solver. And what are we solving for? In this case, we are solving for this sum of squared errors, and we want to minimize this. What are we saying here? Let me close this out. What we're saying is we want this forecast to be as close as possible to the actual data such that the error is small Therefore, the error squared is small, and thus the sum of error is small. And that's our goal. If we can do that by using the base, the trend, and the seasonal factors, then hopefully it would give us a much better type of analysis. All right? So let's go back up to Data Solver. Again, I'm using the sum of errors squared here, and I want it to be minimum. And what variables do I want to change? Well, I want to change the base. I want to change this. And I'm just holding down my control key here. I want to change these as well. All right. Now, don't add your average to the changing variables section. This is going to be a constraint. What we want here is we want to constrain this so that it is equal to 0. All right, and again, because we're using additive, we want to make sure that our average of our seasonality is 0. We're going to use the nonlinear because we're looking at a nonlinear type of equation. All right. Honestly, you probably could, I've never tried it, but you probably could use evolutionary here too. I don't know. It may come out. I should try it one time and see. All right. So we have everything. We're going to hit solve, and we're going to see what happens. Oh, wow. Let's see what happened. So here it's saying that it's not looking at anything. Let me see what's going on here right quick. Okay, so I figured out what was going on here, and this is something you have to be really careful of. So we didn't get any kind of seasonality here. It's 0. And the reason this turned out to be 0 is because we set a constraint of this average to be 0. And the only way right now this average could be 0 is if these are 0. Why is that? Well, in our solver, the default is to make unconstrained variables non-negative, and we want some negative values. That's the only way that this average will come out to be 0, is if we have some positive numbers and some negative numbers. All right, so take out that unconstrained variables non-negative and try it again, and let's see what happens. All right, now that looks much better. And we hit OK. And we could see here that, look at our R squared. Our R squared went up to 0.924. Wow, much better. One of the things I want you to just look at here is our base. Our base is really similar and close to what we had in our linear trend line. Look at that. And our trend is really similar to our beta weight in our trend line. So some interesting things there. But then we have the seasonality that's going on in terms of each one of our months. All right, and we can see in month 1 we're not that far off. Month 2 we're not that far off. Month 4 a little bit more. But we can see that this gives us a little bit better analysis. All right, I'm going to delete this trend line here, and I'm going to try to add in. Let's see if it works this time. Select data. We're going to add in this additive, and what do we want? This, and then here we're going to add in this. All right. Okay. And now we could see The orange is our actual forecasted data. And wow, look how well that fits over the actual data. Much better. And now we can be more confident as we move forward. So I could come down here now and I could simply copy this down 6 months. I don't have anything here, so this should be 37, 38. And we could see what our anticipated sales will be moving forward. And I've gone farther out than 6 months, but you get the idea. And I can actually add that to this data here. Select the data. Let's go here to the additive, edit, go here, and I'm going to extend this forward. Oh, and let's extend this X forward as well. All right. And now we could see how sales look moving forward. And we see that the trend line is still going down, but we can see how it's moving up and down based off of the seasonality. All right, so that is the additive seasonal approach. One of the things I want to do really quickly is to show you how you can compare this to a cycle of, let's say, 6 or 5. How do we know 8 is the best? I mean, 8 did a really good job. It gave us 92.4% explanation of the actual data, and that's pretty good. But maybe 5 will give us better, or 6 will give us better. So a quick way to do this is to simply, and I'm going to copy this sheet just to keep this sheet here. I'm just going to do a quick copy. Let's move it to the end. We can do that. All right, and I'm going to name this one additive -8. And let's call this one additive -6. All right, so all I'm going to do is just eliminate 2 of these cycles here. Just delete these, move up. Our average will change, so it adjusts really well. The problem here is that in our cycle, we still have 8, a round of 8, and we now want a round of 6. So I'm just going to copy this really quickly down. I'm sure there's probably an easier way to copy this down. And, you know, if you guys know that, then you could use that approach. All right, let's see how far down we are. All right, so that is getting us way past the point of where we need information. And you can see here, this is just based off of the data when we were using 8. If we change it to 6 as well, it's way off now. So we're going to have to go back in here into Solver and solve for this again. You probably won't see much change in the base of the trend because it is the base and the trend of the data. What you will see is maybe a change in how the seasonality is approached. So let's just hit solve and see what happens. And we could see that that does an okay job, but not as good as the 8. So this is giving us a 0.721, which is kind of around where we were with the, what was it, the 4-month moving average. So not as good, but you know, okay, maybe 5 will work. Just because 6 didn't work doesn't mean that 5 won't give us a better explanation. So I'm just going to delete one more time, shift up again, we have to change this to a 5, so I'm going to do a copy. Do this down again. And you can see that, I mean, this really is not taking me much time at all to do this. So the benefit of doing this in terms of the time necessary to do it, the benefits, really outweigh the time constraints. And, everything else is basically the same. So just go back up here to Solver again. And you can even see here how my variables that I'm changing has adjusted as well. Hit OK again. And let's see. Oh, this is even worse. And we're now moving more towards something that looked like a 6-month moving average and moving more towards a linear equation. And you know that that's not doing a very good job of explaining anything. All right, so this then is an indication that 8 is a pretty good one. I mean, we could try 9 and see if that works, or 10 or even 12 or something like that, and see if those work even better. But this gives you down and dirty of the additive forecast. All right, I'm back to do the multiplicative forecast, and I'm using the same data sheet. I've gone ahead and just went back to the original data, arbitrary data that we had in there, assuming we didn't have any kind of additive or anything like that. And really there's only 2 things that we need to change in our forecasting. First of all, let's change this so that we know what we're doing. And let's change this so that there's no confusion. All right, so again, we're going to use 8 cycles. Maybe with the multiplicative, 8 cycles is not the best. We did figure out with the additive that 8 cycles gave us a really good forecast. All right. So the first thing we need to do is we need to change our formula. And as you can see, our formula here right now is an additive formula. And if we go back over here to the sheet, we can see that in the multiplicative formula, which is this bottom one, it is the base times trend. And now the time period, this 1 represents the time period. So we're doing this time period and then times a seasonal index. All right. So what we want to do is make some adjustments in terms of turning our additions into multiplication. And then here, this was multiplication, and now it's going to be, it's going to have a power effect instead of just a multiplication effect or a multiplier effect. All right, so let's go back over and let's go in here, and we're going to change this to multiply this. To change to a power, you use the caret, which is this, and then we're going to change this to multiply. It's that simple. I mean, that's all there is to going from an additive to a multiplicative type of forecast. And now I'm just going to copy this straight down. And we know the errors are way off, and that's because right now we have these crazy arbitrary numbers in here. Okay, so the only other thing we need to change is in Solver, remember, we want the overall seasonality, if we were to average this, to not have an impact on our forecast. If we were to do it with the additive, we wanted the average to be 0 because if you add 0 to the forecast, you have no impact. However, if we have multiplication and we have this as a 0, if we multiply this times 0, it's going to have a huge impact. So how do we get this to not have an impact? What do we multiply in order not to have an impact? Well, 1. If we have this average 1, multiply this times this, 1 times whatever, then we don't have an impact. So now in Solver, we have the seasonality to be 1. All right, so we're going to go back in Solver. We're going to set everything up the way it was before, and you can see here it's already in there because of it was already there to begin with, but our sum of squared errors is what we're using as our objective to minimize, and then we're going to change the base, the trend, and all of our seasonal indexes, and then we need to set a constraint. Here, instead of 0, we want this to be a 1. Hit OK, and now we can do it. Solver could not find a feasible solution. Uh-oh. What did we do wrong? Yes, this looks extremely crazy. And so let's go back in here in Solver and see why. You know what? Let's make this non-negative and try it again and see what happens. Okay. You know, I am thinking because we're using multiplication that we might have to use evolutionary. So you see here, even sometimes I have to play around with this and see what happens. I'm going to let this be negative because it should be able to be negative, but I don't know. Let's see. Let's see what happens. All right. It says that it did converge on something. Let's see. But it's still not giving me anything. Okay, I'm going to hit pause right quick and see what's going on here, and then I'll explain once I get back on, once I figure it out. Okay, so honestly, I'm not sure what I did wrong the first time, but this looks much better. I went back into Solver, and I just went, instead of, you know, assuming everything was put in correctly, I went and re-highlighted all of the cells that I wanted to use, just to make sure they were highlighted the way they were supposed to be, as such, and then hit solve, and this is what it came out to be. So you can see that the base is somewhat similar, a little bit higher than it was before and a little bit higher than it was with the linear. The trend is going to be quite different. So what this trend is, remember that we're doing a multiplication. So basically we're losing a little bit of a percentage as we move forward is basically what this is saying. All right, this was 1 or above. If it was 1, it means we're not gaining anything or losing anything. If it was above 1, it means we would be gaining a little bit. But we're losing a little bit, so it's trending down here. We can see the seasonality or the seasonal performance that's going on here. Our R squared is also really good here. It's around 92%. Not as good necessarily as the additive, but it's doing fairly well. We could do the same thing here. I'm not going to go through it, where we Also, compared this to looking at, 7 or 6 or 5 or 4 or 3 or 2 or what have you, and do a comparison and see which one gives us a better forecast. But you get the idea here. And the last thing I'll add to this is that with any analytical procedure, you should always provide a write-up. And the write-up should indicate what you were asked to do, what you performed, what your give something of your analysis. So explain your analysis, and then what are your conclusions. So in this case, you might say that the managers of Ronnie Beach Card asked us perform a forecast for 6 months based off of data that indicated seasonality. This is further deduced when a linear equation did not fit the data very well, and you could say that it was r squared of whatever it was, 0.52, or I don't remember what it was. Therefore, a moving average was used to estimate, and even though there was an improvement, it still did not produce quality results, and you can give the r squared there. The best estimation of, I think, the 4-month moving average gave the best estimation. Therefore, we proceeded to do an additive and multiplicative analysis, both of which produce quality forecast fit trend lines. And you could indicate that, you did an 8 cycle, produced the best fit. You could give the r squared for each one of those, and then you could say that for the next 6 months, here's what the estimated forecast would be. And that's basically how you would do this procedure.
Again, my name is Eric Riney from Webster University. You can contact me at my email information. You can also contact me on Twitter or LinkedIn, and certainly you can find me on YouTube. Join me for another one of my marketing analytics videos. There are more to come, and if you like this one, hit the like button, and you can also join my page. Take care, and I'll see you soon.
Time for new flavor in your ear. I'm kicking new flavor in your ear. Like a brand new flavor in your ear. Here comes a brand new flavor in your ear.
Yes, it's always time for marketing analytics flavor in your ear.